Hi ladies, in this video we're going to go through the theory and beginning questions for 8B, and in 8B we look at unions and intersections, and basically, as you can see on the screen, we use Venn diagrams. So hopefully you've seen a Venn diagram before, but if not, they're not too difficult to understand, but sometimes they are. So hopefully after we've gone through this video you'll develop a better understanding, but if you're still struggling, please ask for help. All right, so let's go through the key ideas. So remember, you should be putting these into your bound reference, either writing them by hand or printing them out and pasting them in your book. All right, so set notation. A set is a collection or group of elements that can include numbers, letters, or other objects. A sample space, denoted by one of these symbols, is the set of all possible elements or objects considered in a particular situation. This is also called the universal set. Okay, so just a few definitions you need to know. So a Venn diagram illustrates how all elements in the sample space are distributed among the events. So here we've only looking at one event, so A. So basically A would appear inside the circle, and this A dash is not A. Here we have, you can see it with B. So A is in this circle. The intersection here is A with B, and then outside is not A. But you can also say outside is also not B, okay, because B would be represented in this circle. A null or empty set is a set with no elements and is symbolized by this symbol or this. All elements that belong to both A and B make up the intersection. So this symbol here, okay, in between the A and the B, and you can say it's an upside down U, is called our intersection. So it means and. So A and B. So if it helps, you can kind of think of and sounding like an N. So that means the intersection. Now, all elements that belong to either events, A or B, is made up with make up the union. So this is the union symbol. So make sure you know the difference between these two, okay, because all these other symbols are probably not used as much as these two. So intersection and union. So you need to make sure you know the difference between the two of them. So A and B, A or B. Two sets A and B are mutually exclusive if they have no elements in common, meaning that A and B is a null set, so they have nothing in common. And usually as if we're drawing the Venn diagram, your two circles wouldn't intersect. So there's A and that's B. Okay, so there's no intersection, so they have nothing in common. For an event A, the complement of A is A dash or not A. Okay, so complement is just, what adds to it to make up to 1. So remember that all probabilities add to 1. So if A was 0.6, then not A would be 0.4. And that's what the next one is saying. So the probability of not A is 1 minus the probability of A, because the two of them together add up to 1. A only, or A and not B, is defined as all elements in A, but not in any other set. So if we were looking at as a Venn diagram, which we've got down here, okay, you can see that is this here in the 3, represented by the 3. The 1 in the middle is your intersection, and then on the other side you've got B only, which is 4, and neither A or B is 2. So that's how you would read a Venn diagram. And you can also represent the Venn diagram in a two-way table. So these two diagrams, extremely important. Sometimes it's easy to read them, but when you're starting out, it can be a little bit confusing. So make sure you understand how to read these two. And hopefully after we've done some questions, it'll make more sense. Okay, so question 1. Oh, my dog just opened the door. Consider the given events A and B which involved numbers taken from the first 10 positive integers. All right, sorry, I just had to shut the door again, although you might hear my dog. She's shaking her head a bit. All right, so let's start again. Consider that given events A and B which involve numbers taken from the first 10 positive integers. Okay, so A, we've got set A is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And B, we're looking at 2, 3, 5, 6, 8, 9. Okay, so they're not the same. Represent events A and B in a Venn diagram showing the number of elements belonging to each region. So in your Venn diagram, let me just get my pen. So always give yourself enough space so you can actually put the values in, especially in the intersection, the middle part that overlaps. Okay, so this usually is A and this is B. All right, so the number 1 is not in space B, event B, so we put that just here. The number 2 is in both, so 2 goes in here. The number 3, let's go in order, is just with B. The number 4 is just with A. The number 5 is with both. The number 6 is in B. The number 7 is just in A. 8 is in both. 9 is just with B, and 10 is with A. So, and we've covered all numbers, so there's nothing on the outside. Okay, so if one of the numbers wasn't included in A and B, it would go on the outside. So, so we've represented it as a Venn diagram. So list the following sets. So A and B. So we've got 2, 5, 8 is a set for that. 2, 5, and 8. So that's your intersection. A or B. Okay, so that, whoops. All right, sorry, I just got distracted again. So A or B means everything in the circles. So basically we've got all your numbers because nothing was not included or on the outside of those circles. So that's the set for A or B. If a number from the first 10 positive integers is randomly selected, find the probability that the following events occur. So the probability of A, so just try to write this notation. I know I haven't really been doing it in my videos, but the probability of getting A. So we've got 1, 2, 3, 4, 5, 6, 7. 7 out of 10, or if you want to write that as a decimal, 0.7. The probability of A, excuse me, A and B is 3 over 10, so 3 numbers are in common. So 0.3, and then the probability of A or B. Siri's just come on my phone, that's so funny. All right, so 10 numbers, okay, so all 10 numbers were included, so 10 out of 10. So the probability of getting A or B is 1. Now, last question, are the events A and B mutually exclusive? Why or why not? So basically, they have numbers in common, so they can't be mutually exclusive. Okay, so if they didn't have these numbers in common, so if you were doing all the odd numbers and all the even numbers, they would be mutually exclusive, but they do have numbers in common, so they're not mutually exclusive. All right, let's scroll down. All right, question, excuse me. Question 4. At a show, 45 children have the choice of riding on the Ferris wheel and or the Big Dipper. 35 of the children wish to ride on the Ferris wheel, 15 children want to ride on the Big Dipper, and 10 children want to ride on both. So let's illustrate that as a Venn diagram. I'll just make this smaller so I can still read the question while doing my Venn diagram. Okay, so drawing your Venn diagram. Now, you may notice the answers in the book will probably put them in numbers. I always find it, oh gosh, that's not a good circle. Oops, let's not do A because it's not A. We're using other letters, F and B. All right, so I find it easier just to put all the values in there, and then you can just count them, or you can count them and just put how many numbers are in there. So if you're not sure what I'm talking about, so let's go back to the previous one. So instead of writing 1, 4, 7, 10, I could just say, well, there's 4 numbers there, there's 3 numbers in the middle and 3 numbers here. So instead of writing what the actual values are. Okay, so let's read the question again. 35 of the children want to ride on the Ferris wheel, 15 children want to ride on the Big Dipper, and 10 children want to ride on both. So I know there's 10 in the middle. So if 35 of the children want to ride on the Ferris wheel, 10 of those want both. So that leaves 25 who only want to ride on the Ferris wheel. And 15 children want to ride on the Big Dipper, but 10 of those want to ride also on the Ferris wheel. So 5 of them are left over. So you can see Ferris wheel adds up to 35, but includes that 10 that want to ride on both, and Big Dipper 15, but the the 10 that want to ride on both. Now we have 45 children all together, and I've only got 40 represented, so that means 5 don't want to ride on the on either. And I just looked over to the question, and I think the answer in the book is wrong. So this should be, that should be a 5. Okay. Question A, illustrated Venn diagram. B, find the number. So see how your notation here, we've got an N and PR. So N is the number. So we're not finding the probability. We want the the number of F only. So only is 25. If we were finding the probability, that's when we would put it over 45. So then question 2, the number of neither F nor B. So you can say not F and not B. It's a bit easier to write, is 5. And then in question C, we're looking at the probability. So the probability of F, I might just write this down the bottom. The probability of F, so altogether is 35. So 35 kids are on the Ferris wheel over 45, and you can simplify that. The probability of F and B, so this middle is 10 over 45. The probability of F or B, so basically how many kids want to ride on a ride? There's going to be 40 of them, so 40 over 45. The probability, and I haven't been simplifying these fractions just because I want to move quickly through the video. So the probability of not F is the 1 minus the probability of F, if it's easier to do that. So we know the probability of F is 35 over 45. So that's going to be 10 over 45. And neither F nor B is going to be 5 over 45. All right, so just make sure you do simplify those fractions. All right, question 6. From a total of 10 people, 5 like apples, 6 like bananas, and 4 like both apples and bananas. Draw a Venn diagram for the 10 people. So let's get our Venn diagram up. Oops, didn't leave much space, but that's okay. All right. So 10 people, 5 like apples, 6 like bananas, 4 like both. So notice I always work out how many like both, and then I do the other 2. So 5 like apples, but 4 of them also like bananas. That means there's only one person who likes just apples. And 6 like bananas, so that means there's only 2 that like bananas because 4 like both. And then how many do we have left over? There's 3. Okay, so think about it as, you've got, all right, we know there's 4 people who like both. Okay, so we've only got 10 people here. Since there's already 4 people who already like apples, okay, they also like bananas, there's only one person who likes apples, okay, because 5 like apples. We've already represented those who like both. And then there's 1 who just likes apples. 6 like bananas. So I've already represented 4 of those people. So there's another 2 who just like bananas. And remember, there's 10 people in common. 10 people in total. 1, 2, 3, 4, 5, 6, 7. So that leaves 3 that like or don't like apples or bananas. Okay? So that's how you represent it in a Venn diagram. All right, so doing that as a two-way table. So we usually say A, whoops, I'm working ahead, I'm rushing, and I make mistakes when I rush. Okay, so A and not A, B and not B. And then let's just draw our table. Scroll down a bit. That should probably be a bit longer. Now, the good thing with a two-way table is eventually you'll be able to fill it in. And I think that's one of the challenging questions I did. All right, so let's go, just scroll up a bit so I can see my sample space. All right, so this first cell here is A and B. And it doesn't matter whether you had A at the top or on the side. So I've got 4 people who like both. This spot here is represented by not A, but they like B. So they like bananas, but they don't like apples. So that's that 2. And in total, there's 6 people who like bananas. So if you read that row, 6 people who like bananas. And they're represented by 4 people who like both apples and bananas and 2 people who just like bananas. In this cell here, we've got apples, but not bananas. So there was 1. And if you read that row, it's going to be 5. Neither apples or bananas goes in this cell. So there was 3. So we add them up and that's going to be 5. So 5 people don't like apples. 4 people don't like bananas. And in total, you can see this row and this column should add up to 10, which is what we have in total. I'll leave you to do this, the ends and the probability, so that numbers. So you can read that straight either from your Venn diagram, but I find two-way tables a lot easier to read. Just remember this probability is A and B, probability of A or B. Okay, so A or B is everything except for 3. So 7 people like apples or bananas. And then I think we get to the challenging questions. All right, girls, bye.